F which is having X, Y, Z. Try to do it X plus Y bar Z. Right, guys? Guys, try to observe in which way it is easy for us. So can we do it with NOR-NOR relation, or can we do it with NAND-NAND relation? Try to observe. I think the same example I have taken here, but it is in the form of complements, right? The same thing, the same thing. So you can do it, convert into product of sums. See, if you try to convert into product of sums, you are going to get X plus Y complement into X plus Z complement, right? As this is the product of sums, it is easy for us to construct a NOR-NOR relation. NOR-NOR relation, right? But to construct the NOR-NOR relation, first what you have to do, you have to take out the circuit, right? So X is one input, Y is one input. I have to have the complement required, and for this I am going to make OR gate, and the same X I am going to give for another kind of expression Z with OR, and finally I am going to perform AND operation. AND operation, right? Simple thing. For this, the parallel equation is, you are going to get X as input, Y as input. This Y NOT gate I am going to replace with NAND gate. Is it NAND or NOR? NOR, because it is OR and form, right? OR and structure. It is easy for us to convert into NOR-NOR. Okay, so this will be right. So it will be represented in the form of NOT gate. I can represent like this, NOR. Okay. Now try to bubble up. If you are going to bubble up, you will get the circuit like this. Circuit like this, and Z, the same X you are going to get here. So as you bubbled up this one, this will be modified as like this. That's it. This is the corresponding NOR-NOR realization. NOR-NOR relation. Guys, can we able to construct in the form of uh, like uh, some of the products? Yes, right. This will be in the form of some of the products only. This will be in the form of some of the products only, right? But the thing is, can we do it, right? Try to observe, try to solve, right? I have a like X as input directly, and Y as input. That will be having a complement as Y bar, and Z as input. And how can you get Y bar Z? Y bar Z as Y bar Z as, you are going to have AND gate, and from this you are going to be written like this, right? OR gate. When you are going to have OR gate, you will do like this, X plus Y bar Z. So this is the corresponding expression, guys. But at this point of time, as it is in the form of some other products, and as we represent in the form of AND OR gate, are we going to construct the respective NAND-NAND representation? Try to think. It couldn't possible, because try to observe, if you are going to have the bubble up here, you can bubble up here. Okay, right? Now can we bubble up here? Can we bubble up on the X side? No, it couldn't possible. Right? So basically what you can do, you can make up one bubble here somewhere, and you can make up one bubble here, one bubble. So at this particular situation there is no problem, right? So try to redraw the structure. So X I am going to get the input that I am going to represent in the form of NAND gate, because I first try to do it a complement. Then Y, again I am going to do the complement for Y. So you are going to get Y complement. Here we are going to get X complement. That X complement, see, observe. So this bubble cancel. That's why I made Z. For Z, I am going to get the data that I bubbled up already. So NAND gate is there, and this entire thing you can represent like this as one NAND gate. One NAND, right? This is the corresponding NAND gate representation for this particular thing. Okay, so try to observe the outputs what is going to happen. Try to check. So if I am going to have give 0 1 0 as inputs, so don't worry about all these things because these are for our understanding. 0 1 0, you are going to get 0 here. Obviously when you get 0 on OR gate, if you get 1 here, then only you will get 1, right? 1, you are going to get 0, here you will get 1 1 1 or 0 0, so total output is 0. Output is 0, guys, right? Can we get the output 0 here? That is what my question. 0 1 1, right? 0 XOR is 1, so 1 will becomes here, and y complement is 0, 1 is as it is. 0 and 1 is 0, 0 complement is 1, 1 and 1 is 1, 1 complement is 0, right? Now both having the same procedure, right? So now these two circuits are equivalent. Circuits are equal, right? So this is the way you can able to represent the product, an expression in terms of NOR-NOR relation, and this will be called it as NAND-NAND realization. NAND, right? Okay, fine. See guys, if you are able to observe, these are the various kind of representations of the same function, right? The same function, right? This is one way of representation. This is one way of representation. This is one way of representation. And another way of representation is Venn diagrams. I have already shown. Another way of representation is connected diagrams. Yes. And another way of representation is truth table. This is for our understandable truth table, right? If you are going to take the two inputs x, y, z, x, y, z, try to observe what are the possible values for all these. The possible values we are going to get as 0 0 0, 1 minute, 0 0 1, 0 1 0, 0 1 1, 1 double 0, 1 0 1, 1 1 0, triple 1, right? See guys, so what is this x plus y bar z equation? That is what my point here. I'm going to simply divide it. X plus y bar z, y bar, see basically you can do like y bar z again one equation, then you can solve it, right? I will also do the same thing, so it's easy for me to calculate. So y bar z I will first calculate, then I will try to do x plus y bar z. This is my final, right? Y bar z is like multiplication, right? Y bar is 1, 1 into 0 is 0, and this is 1 into 1 1, 0 into 0 0, 0 into 1 0, this is 1 into 0 0, 1 into 1 is 1, 0 into 0 0, 0 into 1 is 0, right? I made directly, right? Now x plus y bar z, guys, as I am trying to perform OR operation, wherever x is there on OR operation, always you are going to get output 1, right? So that's why I made directly, or else even 1 or 0 is 1, 1 or 1 is 1, 1 or 0 is 1, 1 or 0 is 1. Now here try to do an OR operation, so here only you will get 1 and all the remaining cases you are going to get 0. This is the another representation of the same expression x plus y. Guys, actually what we did earlier, from earlier onwards I am trying to say, wherever you are going to have ones, try to take out that as one expression. Try to take out that one expression and try to simplify it, right? See, try to observe this particular thing. I am going to represent it as x bar y bar z plus x y bar z bar plus x y bar z. See, I am trying to write all the ones, okay, plus x y z bar plus x y z. xyz, right? The same expression, right? This is in some of the products. So standard sum of the product, not some of the products also. Standard sum of the products, right? I can represent as summation of 1, 4, 5, 6, 7, 8, right? So like this different ways you can able to represent everything. Okay, fine. So I hope you understood clearly. Fine. Uh, okay. So if anything is there, we'll continue in the next class. Thank you.